So let's go ahead and take a look at a few more problems on our final. We're beginning with where we left off. We just got done with number 7, and now we're going to take a look at number 8. Now, number 8 is one of those problems that is actually super easy, but it's only super easy if you know what to do. And I'm hoping that if you watch this, when you get to the actual test, you'll say, oh, I got this, no problem. Because this is basically just testing as to whether or not you understand what function notation is. So we're asked to evaluate the function p of x is equal to -3 plus 4x when x is equal to -2, 0, and 5. And this is written as p of 2, -2 is equal to, p of 0 is equal to, and p of 5 is equal to. And all we need to do is we just need to plug in for x, -2, 0, and 5. That is all. And I really don't want anyone to miss this question because it's not hard. The math is not difficult. Or I should say the computations are not difficult. So we're going to plug in -2 for x. So we plug in -2 where there was previously an x here, and also where there was previously an x right here. So as you can see, this statement is the same as this one. The only difference is now where we previously had x's, we now have -2's. So we had x's here, we had x's, and now we have -2's. So let's evaluate p of -2. We have -3, 4 times -2 is -8, so we have -3 minus 8, or rather p of -2 is equal to -3 minus 8. P of -2 is equal to -11, consequently. So our first answer is -11. Let's go ahead and look at the second one, p of 0. P of 0 is equal to -3 plus 4 times 0. Once again, we replace x with 0. Conveniently, 4 times 0 is 0. Therefore, p of 0 is equal to -3. Nice. That one was the easiest part of what I'm hoping will end up being a very easy problem. Finally, we need to look at where p is equal to 5. So we have p of 5 is equal to -3 plus 4 times 5. Once again, where there was previously 4x, there's now 4 times 5. Where there was previously p of x, we now have p of 5. In any event, p of 5 is equal to -3 plus 4 times 5, which is 20. And as a consequence, p of 5 is equal to positive, I almost wrote a negative, positive 17. So those are our 3 answers. I'll go ahead and write that in over here. And I'm hoping this is going to be a gimme for all of you on the test, and you won't have too much difficulty with it. On a similar note is simplifying on number 9. Now, number 9 is, quite frankly, completely unrelated for number 8, but let's go ahead and take a look at it. So on number 9, we have z to the 8th power times z to the 2nd power divided by z to the 5th power. And we're asked to rewrite this using only positive exponents. And what we need to do is apply our product and quotient rule. Now, product means multiplication. So that means we need to look at z to the 8th times z to the 2nd. And we need to write that as a positive exponent. And how many z's do you have when you multiply z to the 8th times z to the 2nd? Well, z to the 2nd, just to give an example, z to the 2nd is literally equal to z times z. It's equal to z multiplied by itself, the number of times that are in the exponent. This means that z to the 8th times z to the 2nd is z multiplied by itself 8 times, multiplied by z multiplied by itself twice, meaning our top is actually going to be z to the 10th power. And our product rule just says that when we're multiplying two different variables or numbers that have the same base, we can just add the exponents together. Here, we get our 10 from adding 8 and 2 to make 10. On the bottom, we have z to the 5th still. And now we need to apply our quotient rule. In our product rule, we added the exponents together. Our quotient means divide. And that means that since we have z to the 10th divided by z to the 5th, since we added when we multiplied, now that we're dividing, we're going to subtract. So z to the 10th divided by z to the 5th is z to the 10 minus 5, aka z to the 5th. So our solution is z to the 5th power. Now, the reason why this is the case is because if you were to write out the top over the bottom, we would have z times z times z times z. That's 4, 5, 6, 7, 8, 9, and 10. Well, let me double check this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. And then it's divided by z to the fifth, which is z times z times z times z 5 times. And when you have a fraction like this, if the same thing is present in the top and the bottom, you get to cross them out to get rid of them. So these cross, these cross, these cross, these cross, and these cross, leaving us with 5 z's on top, which end up being z to the 5th power. I don't recommend doing it this way. I recommend just memorizing the rules because it takes forever to write that out. Now, moving on to number 10. This is another fraction or exponent problem, excuse me. And this one is pretty similar to the last one. Well, not exactly. This time we're applying a different rule, and this is our power rule, or our power to power rule, as I frequently call it. So since this is a power being taken to another power, we need to take everything to the third power. Now, -5 to the third power is just -5 to the third. Not anything very interesting there. Now, p to the third power, however, is a little different. We have p to the third, and when you take a power to another power, it ends up being p to the 3 times 3. The reason that's the case is because p to the third power cubed, or p to the third is equal to p to the third times p to the third times p to the third, or p to the third times itself 3 times. 3 plus 3 plus 3 is 9. So this is basically just repeated addition, gives us multiplication instead. In any event, you can just remember, oh, I just need to multiply the powers when it's power to a power, because the product and quotient rule are when you add or subtract. So we just need to evaluate this. -5 to the third is -5 times -5 times -5. -5 times 5 is 25, times another -5 is -125. And p to the third is just p to the 9, or p to the third times 3, or p to the 3 times 3 is p to the 9. Therefore, our answer would be these two things together, which is -125 p to the 9th power. So that's our solution, -129 p to the 9th power. All right, that one was fairly straightforward. And we're going to go ahead and look at number 11 before we cap this video. So number 11 is all about using our distributive property. And our distributive property, in this case, is distributing z minus 5 times z plus 3. And the way I like to distribute it is I like to distribute the z term over the second set of parentheses and then the -5. So I would write this as z times z plus 3. And also -5 times z plus 3. So there's our first term being distributed and our second term from the first set of parentheses. Z times z is z squared. Z times 3 is just 3z. -5 times z would be -5z. And -5 times 3 would be -15. From here, we're then able to combine our like terms because we need to add up all 4 of these. Our z squared cannot combine with anything else because in order to combine like terms, they must both have the same variable and the same exponent attached to that variable. Z squared does not share an exponent with 3z or -5z because both of those are implied to have an exponent of 1. So the regular z's can only play with the regular z's. That means that z squared goes to the end. 3z minus 5z is a -2z, and -15, which can't play with anything else because it doesn't have a variable. And that covers this problem. The only other thing I'd like to mention, z times z. When we did that distribution, z times z is z squared. And this should be relatively obvious from some of the work we've been doing with the exponents in the previous problems. But if it helps to think about it in terms of a product rule, you can think of z times z as being z to the first times z to the first, which then gives you z to the 1 plus 1. If you already understood this and didn't have a problem with it, I wouldn't worry about this part. Just know that z times z, or x times x, is x squared or z squared or whatever the variable is.